Hi everyone, thanks for joining today's tech session. This is Lakshmi Srinivasarao Kothamasu. I have around 22 years of experience in building data pipelines as well as data analytics platforms across on-prem and cloud platforms. Over the years, I played roles of data solution architect and technical lead as well as data engineer lead. During this whole time, I was worked on wide variety of databases, ETL, ELT tools, programming languages, scripting languages. So today's topic is self-healing data pipelines with generative AI. Before we deep dive into self-healing data pipelines with generative AI, I would like to give first what is data pipeline, where exactly this is used. So data pipelines are the process or a framework to move data from wide variety of sources that can be flat files, XML files, IoT devices, databases, cloud native platforms to respect to downstream systems, which can be Oracle database, Snowflake database, or reporting systems, Salesforce, CRM applications. So overall, for any data analytics platform, data pipelines play a major role to identify the sentimental analysis of customer as well as predicting the data of near future terms or identifying the latencies or customer behavior. Having said that, let me go to the current modern data platform pipelines challenges. So the current modern data pipelines have three kinds of problems. One is a silent failure, second one is high measuring time to response or measuring time to repair, and third one is brittle automation. So when it comes to silent features, those can be schema drift. If we talk more on schema drift, it would be like changing the data type of upstream system without informing to downstreams, or changing the constraints, or changing the data length, or renaming the columns. So all these scenarios, the current data pipelines will fail, saying that some kind of constraint violation or data is getting truncated or the column is dropped. In terms of late arriving data, which is something because of the some data issues, upstream is not able to process the data. That time also we'll have late arrival data. Because of that also data pipelines fails. So in order to fix these problems, currently cloud engineers or data engineers spend hours triaging where is the problem, how I can reproduce the failures, how to let's say after fixing this reproducing the failures, it will be like a lot of coordination efforts between to fix to apply in dev QA to prod. And third one is brittle automation. These rules currently monitoring based upon some static rule like or some latency, some hours. So these are all the current problems with the modern data pipelines. How these can be achieved using self-healing data pipelines. What does really self-healing means? It means that automatically detect anomalies, identifying the root causes, and what could be the next best action item before it will get impacted to downstreams. So with the help of generative AI data models, there will be three or more ways to identify this. One can be autonomous detection, intelligent diagnosis, automated recovery, and continuous learning. These are the four steps self-healing architecture mainly residing on. we further deep dive, the architecture is it's detecting, diagnosing, remediating, optimizing. So where exactly this problem is happening and how do I diagnose? What would be the remediation steps? It's not going to happen again. So let's move on to next slide. In the step one, transformer based autonomy anomaly. So here first we have to define how do I identify anomaly. So anomaly is something it is not working as expected. So which means that we should be knowing what is the expected behavior. Once we know the expected behavior, so we can easily identify the anomalies. So how the models can determine these anomalies? So models will work on trained data of historical pipeline telemetry, identifying the distributional shift as well as threshold breaches, low false positive rate via attention weighted context. And fourth one is works across batch and streaming pipelines. So how does it work? So we will be identifying this telemetry matrix, identifying the row count, SLA latency, NLA rates, and as well as by reading structured, unstructured log streams to the unified feature space. And this model architecture, which is time series transformer, which is multi-headed self-attention, so that it automatically fine-tune domain-specific pipelines telemetry for each business unit. And identifying the score, what would be the anomaly score, which is defines the how bad that particular identification, how bad the detection of this. And second step is LLM powered root cause analysis. What it means, like when anomaly is confirmed, LLM has to identify what's the root cause. How it can be identified? By reading the event summary, which means that when this event has been occurred, what are the jobs it's got affected, what's the failure type, and what is the severity score. And at the same time, it has to read all the logs, error messages, volume details. The third step is what's the impact of upstream dependency and what is the lineage, how it is going to affect for all schema versions. And is there any historical events happens like this kind. And the third step is how do we remediate? In terms of remediation, is there any process can be built which automatically looks for retraining orchestration? This will work fine when you have some timeout issues, when you have environmental issues. The retry orchestration will help to rerun the logic. Schema auto repair. It's like detect and patch schema drift generating mappings, which means that let's say if any upstream changes not null to null constraint, it's okay to change the target system automatically. There is no impact to the business. Data quarantine. So which means that is there any data corrupted? So let's say if we have some millions of rows, out of those million rows, 10 rows got impacted. Instead of bypassing an entire job, you can partition or you can isolate that particular bad data set and prevent the failure not to happen to the downstreams. And dependency rerouting, failover to secondary data source when upstream APIs degrade. The fourth step is escalation logic and human in the loop. So let's say if we talk all these things, always remember the self-healing is not a fit for in all the places. It all depends what's the severity of that error, how much AA level metrics is confidence levels. So in this scenario, the way it has to be like 3 tier. It's tier 1, it can be fully automated When it is fully automated, we would like to understand it has high confidence, low risk, immediate remediation. In terms of when a human override window, which means that whatever the output produced by AI models, if it has a medium confidence or risk, then it's better to have human in the loop. Third is very low confidence, high impact, approval required for any action. Because why it has to go these three? Because all three have a major role to play. It and also, as I said, self-healing, it does not fit for every place. It has to be segregated as well as identify the impacts, then only decide which tier your project can fall into. Okay, and because in overall this picture, the guardrails, governance come to the picture. What will be the if AI models are do more hallucination, what's the downstream impact? How it will be impacting for the other places? So one is like adapt to resource optimization. Let's say self-healing pipeline does not fix failures, but it prevents them. How what it means is predicting the resource contention before it causes latency spikes, or adjusting scheduling windows during upstream API congestion, or reducing the cloud spend by eliminating our provisioned headroom. So observability governance, this plays a major role. Observability governance plays a major role because all AI models has to be have fully observed and has the proper auditability and feedback loops as well as governance control. In terms of fully observability, unified telemetry across metrics, identifying what is every AI decision surfaces with reasoning. Governance controls is something like policy as a code constraint. Auditability is all action logs happens between whole this model to work on has to be captured in audit logs so that it can be used for next future use cases, as well as it's one of the requirement for especially in regulated industries. And human overrides is required when there is a sensitive data or sensitive action item will impact for the downstreams. So self-healing can be applied across multiple services, and also at the same time we have to understand if we do the fully automated, what would be the things has to be taken care from each project perspective. Let's say in financial services, it's okay to use self-healing to identify real-time fraud pipeline, the real-time fraud scoring. In case of e-commerce, it can be used to identify inventory recommendations during peak traffic surges. And the schema drift, identifying the schema drift, let's not fail the pipeline, it will automatically detect and update the pipelines accordingly. But in the case of healthcare, where the pipelines are reading electronic health records, where it reads patient data, lab results data, and medical dosage data. So it is where it is very important to have human in the loop, if to identify the next best course of action. If let's say if human is not in the loop, based up, and if we give full authority to the AI agents, it may impact patient's health, or it may give overdose, and it may boil the patient's health. It will be a very, very danger impact to the downstreams. So All what we have to decide is when and what level this self-healing is required, what could be the impact to the organization, and what are the best use cases where you need to have a human in the loop. Having said that, this is the production readiness checklist. Let's say if you have to build this process, so one first part is identify what is your baseline telemeter and what is your RAG runbook. RAG is nothing but it's retrieval augmented, which means that understand from the history data, identify the patterns, identify the long runs, identify the what are the failures happened so far. And third step is confidence. Like what's the overall model confidence? It's high, medium, or low. So let's say this whole 1, 2, 3 first two steps are done. Second part is let's run this model in shadow mode first. Run the recommendations until you have a confidence. Second is having a data governance in place, guardrails in place, and keep those guardrails as policy as a code. Third, having a human in the loop, which is the feedback pipeline, which will this feed overrides and outcomes back into retrain. So what would be the TKOs for overall? Like we have to identify 4 steps. Detect intelligently with the help of transformer based models. Diagnose with context with using LLMs grounded RAG, which will be identifying the telemetry logs, reading the logs. And third one is remediate responsibly, which means that take care of data governance guardrails in place so that it will not be violating current company compliances policies. And fourth one is build for resilience, not just recovery, making sure it helps prevent future failures before they occur. Thank you, everyone.